Hi everyone, this is coming to you from Education for All. We are going to look at, is it better this way? I don't think so. It's better like this. We are going to solve two problems under epsilon delta definition of a limit. We've progressed to this level where now we are going to look at proofs. We want to prove that the limit exists, or if it does exist, then prove that the function is correct. We got two problems here. Problem number one says prove the limit as x tends to 2 of the function 3x plus 5 equals to 11. And the second problem says prove the limit 3x minus 1 as x tends to 2 equals 5. These are simple proofs, but we'll start from there before we progress to more difficult ones. Now, remember the definition for a limit using the epsilon delta definition of a limit, because that is what these problems are talking about. Let's look at the first one. Let me use. Let's look at the first one, problem number one. It says the limit as x tends to 2 of 3x plus 5 equals 11. Right, so what is this saying? Intuitively, what this problem is saying is that if you replace x by 2 on the left hand side, then you will get your 11 on the right hand side. In other words, if you say 3 times 2, this is x now replacing with 2, plus 5, so this gives you 6 plus 5, that is 11. Intuitively, that is what that function there is talking about. But if you want to prove it rigorously, you can state that no matter how small, according to the epsilon delta definition now, no matter how small, this is a distance, x minus 2 is, no matter how small x minus 2 is, we can make 3x plus 5 minus 11 small as well. This is the epsilon delta definition, rigorous proof. No matter how small by making x minus 2, no matter how small by making x minus 2 small enough, we can make 3x plus 5 minus 11, the absolute value I'm talking about here, as small as 1. Remember that graph? No matter how small we make this, we can always be able to make this one small as well. Remember that graph? That straight line graph? This is your x here, and this is your y here. So if you can make this one here small, let's say this is your, just for illustration purposes, this is your 11, your limit is 11. So if you can make So you can say this one is x minus delta, this is x plus delta, and this is, let's see, the function f of x plus, let's say, y plus epsilon, and this one is y minus epsilon. So no matter how small you make x, the absolute value of x minus 2 is this value here. No matter how small you make it around your limit, you can always you can always find value. No matter how small you make this here, you can always find value such a way that the absolute value, the limit, is always within your tolerance. That is what this is saying. The idea is abstract, I know. I mean, it's a very abstract idea, but it's correct. No matter how small, because this is your input here, and this is the output. No matter how small you make this, you will always find the limit within this range, x minus delta, and x plus delta. I hope you understand that definition. So now, let's solve the problem. Let's solve it now. Let's do the proof. This was intuitively. You state, for all, let me use terms. For all x, for all delta, for all epsilon greater than 0, there exists this is what you see, there exists delta greater than 0, such that the absolute value x, now we'll put this one here, x minus 2 less than delta, implies that the absolute value of 3x plus 5 minus 11 is less than epsilon. This is the condition you have. What we just explained previously, this is it. In other words, this is your fx minus your L inside here. This is your limit, this is your function. Well, just want to, and this is your, of course, your x minus I. You know this already. Yeah? Just for you to understand what we are doing. So it's not required. So after stating this condition, that there exists an epsilon greater than 0. Sorry, for all epsilon greater than 0, there exists a delta greater than 0, such that the absolute value of x minus 2 is less than delta. If that is it, then it implies that the absolute value of the function minus the limit is less than epsilon. So now our next target is to find epsilon. When you look at this statement, you mathematically, this means this value here is the input. This is the output. It's like you are given this from this statement. You are given this value and you want to find this delta. So that is what we do here. That is what the definition of epsilon delta of a limit is talking about. You are given this and you want to find this. So now let's carry on. Let's carry on how we do it. So you start with what you are given. We are given this, the absolute value of 3x plus 5 minus 11 less than epsilon. So we can state we want to find delta using what we are given, 3x plus 5 minus 11 less than epsilon. So what is this? Let's break down what we have inside this absolute values. Yeah. So we'll have 3x plus 5 minus 11 less than, let's find a value here. This gives us 3x minus 6, not so? So this gives us 3 into x minus 2, right? And we said this one here is less than delta, yeah? Is less than epsilon, right? From here, this is what we are just trying to break down. That value, 3, the absolute value of x minus 2 times 3 is less than epsilon, correct? But what do we have for absolute value of x minus 2? We have stated here that the absolute value of x minus 2 is less than delta. X minus 2 is less than delta. So what we need here, this is now 3 times delta is less than epsilon. Can you see that? Because this is delta, but it has a multiplication here of 3. So 3 times delta is less than epsilon. It's delta we want, yeah? So delta here is therefore epsilon divided by 3. Now we got a value for delta. It's too bright. I think it's better this way and this way. Now we got a value for delta. We now need to find, we now need to prove the function that indeed that function has a limit which is 11. So how do we go about that? How do you go about that? We now know that, I'll take off some. I will take off this for space, please. We now know that delta equals epsilon. This is epsilon, yeah? Divided by 3. I don't know how to make them look different. Is given. We let this one. And we know delta greater than 0. This is given. right? It was given to us, delta is greater than 0, right? And now we have found the value of delta to be epsilon divided by 3. So then, for all x, this is greater than, this is this for all x. For all x, right? So the next thing now is the proof. Now the proof follows. First thing you do, you try to find the value of delta. Once the value of delta is determined, now the proof becomes easy to do. If you start with the with the proof by stating this thing: if x minus 2 is less than delta, if the absolute value of x minus 2 is less than delta, then you know this: 3x plus 5 minus 11 is less than epsilon. Let me put this there, right? You know that is the thing. If absolute value of x minus 2 is less than delta, then 3x plus 5 minus 11 is less than epsilon, which is correct. But what do you want to do here? We found delta using epsilon. Now we want to prove the function is correct. So what we do now, we are using this function here. This one here we have. So this one will give us 3x minus 6. This one. Yeah? So this gives us, this breaks down to 3 into x minus 2. Correct? 3 into x minus 2. And then we know but we already know, but x minus 2 is less than delta. Yeah? X minus 2, we stated it here. We just erased it because we needed space. X minus 2 is less than the absolute value, the absolute value of x minus 2 is less than delta. Therefore, 3 into x minus 2 is less than 3 delta. Yeah? Because this is delta. So you have 3 here. Correct? But what is delta? But we have delta is equals to epsilon. Epsilon all over 3. Therefore, we know what delta is, yeah? It's epsilon all over 3. So therefore, this one here 3x minus 2 less than 3 delta. Now, because we know the value of delta as epsilon all over 3, so this becomes, we still have our 3. Now your delta here is epsilon divided by 3. So you find out that the 3 cancels. Yeah? The 3 will cancel. So you'll have your equation x minus 2 is less than epsilon. So this ends the proof. You've now proven that, in fact, this equation, not this one, this equation, you should write the full equation. 3x plus 5 minus 11. Although it will be like this, but this is what you write. This is what you want to show. The function here and the limit is what you want to show. So no matter how small you make epsilon, you can always get a value delta that will allow the limit to be within that range, plus or minus x plus delta and x minus delta. So that is where the proof ends. Thank you for watching.